All right, welcome to Python 102. If you have access to Moodle, I've just uploaded, well, I uploaded about an hour ago. It's the session code for 102. It's this search sort. We'll be using the Wikipedia fruit data text and also this file today. So these are the two files you'd want to download and put in the same directory, so that, and then you can open up Jupyter Notebooks and go in and open up those the session 2. Sorry, Andrew. Yeah, I'm still catching up, so I still owe you guys grades for Python 101. Hopefully by the end of this break. I mean, not by the end of this break, by like the end of this weekend. All right. So in my Jupyter Notebooks, I see these 3 files, the session 1, Python 102 session 1, session 2, and the Wikipedia fruit. So I'll open up the session 2, which is here. If you're doing this on GitHub, it's also available on GitHub here in the Python 102 folder, session 2 Wikipedia fruit. So that's if you're not able to access Moodle. Okay. So I switched this around a little bit. I think today we're going to work on search and sort. I think next time maybe matching and parsing. I'm just trying to find, at this point we're beyond like basic Python, right? Python 101, and now we're kind of moving into different tasks and different things. And I'm trying to think of very general tasks, very common tasks that you would do, whether you're in, whether you're doing data science on numbers, or whether you're dealing with text. So today we're still going to be dealing with text. But also some numbers like together, and then so today we'll cover search, searching in strings, and in particular these. I'll show you some like basic search functions. We talked about the in operator before, the find function, but then we'll move on to kind of more interesting search tools like these. It's called regex. Regular expressions. I'll introduce the concept of regular expressions, and we'll do an exercise with that. Then I'll introduce some basic sort functions, the sort function, and also key and lambda. So lambda is kind of we talked about functions before, right? We introduced basic functions. Lambda is not specific to sort. Lambda is a kind of a mini function that you use inside of other functions, right? And I'll show you kind of what lambda is. It's a very useful tool, but it's a little tricky to use it the first time around. So I'll introduce that as well in conjunction with the sort function. And then we have a couple of other exercises, exercise 5 and 6 that we can work on. So probably like 2/3 lecture today, but 1/3 kind of you working on things, and then us coming back and evaluating it. So okay, so to introduce sort, let's start with this basic string. Apples are so delicious. I love apples. We can use the in operator with strings to find substrings, to check whether a substring is contained in a string or not, right? If we look at, also this in is case sensitive. So if I look at delicious with a capital D, right? It's not in there. We also have the find function. So sometimes the in function, the in operator is just going to return a true or a false, right? Which is very helpful if you're using it as a condition, say in an if statement, right? If something is contained in something, if this keyword is contained, if the substring is contained in a string, then do something with it. If not, then right. So, but sometimes you also might want to find like the index, like where in that string is the substring. So the find function will return that. So 14 here is the index. So if you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is the index in the string where that substring begins, right? So you can use that. But those are pretty limited, right? Between the two of those, you can do a lot. For example, like, let's say you want to return the front part of a string up to the keyword. So any ideas about? So S find. So what I want to return is I want apples are so, like this. I want the front part of the string up to the keyword, right? And then let me give you one other task. How about return the end part of a string, the last part of a string beginning with the keyword. So, so that would be like this part. So go ahead and try that right now. We're obviously going to use this to index it, but exactly, so like what else do we need to write to? So here's 3 different tasks, right? They're similar, but slightly different, right? So who's got this one? Anybody else got this one? Working? You got it? All right, go ahead and give it to us.
So we have to write the name of the array S, then parentheses, open, no, square ones, yeah. Then we got 2 dots and parentheses in the end.
Okay, great. So I'm just going to put some spacing here so we see what we're doing, right? So we've got S, we've got the string, and then we're going to use this colon, right? Where you can put the starting index and the ending index, right? And then the starting index, if it's nothing, right, then that's going to start at the beginning of the string. And then we're going to end it with this index, right? So that gives us the apples are so. Okay, and then for here, Seema? Oh, for this one, you did a different way?
S equals to S in square brackets.
S equals,
Equals to. No, S equals to. S. Yeah, in square brackets. 14 dots. 2 dots.
14.
14, 2 dots.
Like this.
Yeah, it's equal to S.
I'm not gonna resave it because I want to keep using S, but okay, like this. Did you put the number 14 or? Okay. So if we
is delicious. Delicious.
Right. So if we want to use this, if we don't want to hard code the index, though, if we want to identify the index using this function, right? So then we could do the same thing. Right? So, and then this is going to give us that 14, right? And that'll give us delicious, I love apples. And what if you want, so apples are so, that stops us at the first entry of, right, the first instance of delicious. But what if we actually want to include that word? So we want to include apples are so delicious.
But we have to just print. Plus. What?
So we'll do the colon. So this gets us up to index 14, but we want to push it a little bit farther. How much farther do we want to push it? We want to push us the length of the string delicious. Yeah. So plus length of delicious. And that should get us. So that's going to get us to the 14 and then plus the length of delicious, which is enough to include delicious, right? Oh, sorry. Am I not sharing the video? Oh, no. Oh, yeah, I'll share the video. Sorry. Yeah. Yeah, after today, I'm going to upload session 1 and session 2 to YouTube, and I'll put the links up. So, okay. So there's a fair amount you can do even with the find function, right? Like once you know the index of that string, like there's a lot you can do. You can kind of play around with it. But regular expressions give us like infinitely more like alternatives. So regular expressions are also are not specific to Python. So every programming language that I'm aware of like incorporates regular expressions. Regular expressions are kind of a generic set of it's a kind of syntax that lets you identify variable expressions. So let me open up this link here. This is the W3 Schools tutorial that we love so much. So regular expressions in Python, so a regular expression is a sequence of characters that form a search pattern. So it's a very common way to search. And if you're doing like corpus linguistics or anything with text at all, like it's good to become familiar with regular expressions. And that knowledge, like if you're familiar with regular expressions, you can use it in Java, you can use it in JavaScript, you can use it in Python, you can use it anywhere, right? So in Python, there's a built-in package called RE for regular expressions. To use it, you're going to import RE. The main functions are find all, search, split, and sub. Today, we'll use the find all, search, and split functions. We'll use 3 of these. If you go down here, here's the syntax, like some of the meta characters in regular expressions. So if you want to identify like a set of characters, you'll use these brackets, like backslash for a special sequence. I'll show you kind of how to use these. A dot can represent any string. So for example, if you write a string like this, he.o, what could this string represent?
Similar to what?
So
Or any characters.
each of those dots could be any character. So if it's he.o, it's
2 words, 2 letters.
2 letters, 2 numbers, 2 characters. It could be he**0. It could be hello. It could be helpo. It could be he120 or o. Right? If you those dots can be anything except for a carriage return, like a new line. This caret and the $sign are like look for strings that begin with this or end with this. if you have a star, that means you can have multiple occurrences. So this star is like following the period here. So if you have HE dot star 0, this will accept anything of the form HE something 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 0, right? So and with the star, it could be as many somethings as you want, right? So let's replace the dot with the L. If you had HEL star O, what kind of strings could that include?
One L
Mhm.
to a lot of L's.
Right. So it could be HELO, it could be HELLO, HELLLO, HELLLLO, right? So this regular expression would give you, and the star means it could be 0 or more. So it could also, this could also be HEO, right, with nothing in there. Right? But then the plus requires it to be at least one or more occurrences. So if it's HE dot plus O, then it has to be at least HELO, but it could be more than one L, right? And then if you have the bracket 2, then it has to be exactly that number, right? So HE dot O, HE dot with a 2 bracket and then a 0, that means HE something something O, and there have to be 2 of them exactly. Yeah. Okay, so you can also have or like either this one or that one. So, and then there are other kinds of things here. So and here are some sets. So for example, ARN, this is like a match where one of the characters A, R, or N is present. And then like, these are really common, like 0 through 9. This could be, it's like one character, but it could be any number 0 through 9. And then if it's AZ, it could be any character like uppercase or lowercase, right? So, so let me give you some examples. So first we have to import RE. Here's our example sentence. So what if we want to find all of the apples in this sentence, whether they are uppercase or lowercase, singular or plural? So what would a regular expression be that would give me uppercase and lowercase, singular and plural? I'm just going to put in apples here. How would I need to change this?
A or like uppercase A.
Right. So I could do it like this. Okay, so this part here, uppercase or lowercase a, is going to let me choose one of the two, right? And then the PPLES, and that'll give me app pull. And what about the S? You could just drop it, right? Because as long as you have apple, it'll give you apples. So let's try. So now I'm going to do RE dot find all, and I'm going to put this. I put the find all function has 2 parameters, my regular expression and then the text. So my text is, or the string is S, right? And I run it, and I've got A and apple. So this OR is doing A or apple. So that's not what I wanted. I only wanted the OR to apply to the A, not to the whole thing. So if I put brackets around this, like this. So actually, you don't even need this. You can just do like this, AA. Right? So that's a set. And as long as one of those two things is there, it'll accept it. Right? So the set, of that set, I have to either choose a capital A or a lowercase a, and then pull. So as long, and so if you look at, so if we do this, look at apple. The problem is it's not picking up the S, right? So how can I include the S, but 0 or more or 1 instance of? So I think actually this question mark, right? So the star will give you 0 or more occurrences, but that could include apples with 1,000 S's, even though we don't have that, right? The plus would require the S to at least one S to be there, and that wouldn't give us the singular case, right? But the question mark gives us 0 or 1 occurrences. So that's exactly what we want, right? So you can do apples with the question mark. So it's going to apply that question mark to the S, I think. Right. And then it gave us the, it captured those. Now, if I say, let's say my string is apples are so delicious, I love apple, just to test it, right? And it gives us the apples with the S uppercase, and it gives us the apple lowercase without the S. And so this is a regular expression. And this syntax, again, is not specific to Python. This syntax is universal in regular expressions implemented across all different programming languages. So how would I do, how can I, what's a regular expression I could write to remove all punctuation from a sentence? All I want are uppercase and lowercase characters and numbers and white and spaces, but I don't want any, I want to preserve the white spaces too, but I don't want any punctuation. So any ideas here? I'm going to be using sets. What sets could I use to remove all of the punctuation? If you're on Zoom, you could type the regular expression into the chat if you want. So we've got lowercase to uppercase z, we've got, sorry, A to Z lowercase, we've got A to Z uppercase, and we've got 0 to 9 for the numbers. So here, any ideas? What would our regular expression be? Basically, you want all of the numbers and letters, but no punctuation. So, any thoughts? So I want lowercase, I want uppercase, and I want numbers. As many as there are. Right, so this is a set with lowercase, uppercase, and numbers as many times as they appear. And anything that's not in those sets is going to be removed. Right? So I can do regular expression find all, apply that to S. Let's see. So this is giving me the words. And if I just want, if I get rid of this, it'll give me all the letters one at a time. So this is, if I do it without the star, it'll give me every instance of a letter or a number, which is not punctuation, right? What if I want to preserve the white space in between? I can include that in my set like that. And now I have it includes the white spaces. I could add the star, and now I get a list with each item. It's only broken up when there's a punctuation, right? And then if I want, I could rejoin these, right? So have we talked about how to rejoin the elements of a list? So there's a join function. It looks like this. So if you have strings in a list and you want to concatenate them, right? Like here you have apples are so delicious. I'm going to get rid of this for a second. Yeah. Oops. So if you have apples are so delicious, space, I love apple, you can use this join function, and anything, you could put this list into the join function. Oops. And then it'll join them, it'll join each of these with whatever string you specify here. So this is your delimiter, right? Between the, so if you just like make it nothing, like a null string, then it'll return like this. And if you make it like a space, it will add an extra space. So now you have apples are so delicious, I love apple, with no punctuation. So you've removed all the punctuation. Let's try a third one. Let's look for what kind of regular expression could you write to find the word in front of apple? It's going to be, huh? This one? Starts with apple? Like this? So this is looking for instances where the string begins with that. So, but you want something, you want a regular expression with apple in it, but then something here in the front, right? So how could you write a regular expression to indicate, right? There's going to be like a word and then a white space and then apple. So what will go in here? Any ideas? How can you represent a word and then a white space? What's a regular expression? What's a regular expression for any word? Any thoughts? So for a word, you just want, now here, let's just say it's lowercase. It's A through Z. A word is just something A through Z repeated at least one time. And then we want a white space, right? Like a space between them. So this A through Z is any like character, and then the plus means it has to be at least one or more. So it's any word containing a character, at least like one or more characters, followed by a white space, followed by the word apple, right? So this regular expression is going to give you a word, space, and apple. Any time that there's a pattern with a word, a space, and apple, then it'll pop up, right? So that gives us love apple. And then if you want to find the, let's call this the output, or let's call it, then how would we, I just want, so this is how we found the word in front of apple using that regular expression, but now I just want the word love. I want to drop the space in the apple. So how could you do that? So here we don't need regular expressions. Or you could use a regular expression, but anyways, you just want the first word. You don't need both words. Any ideas how to just get the first word there? On Zoom, do you have any thoughts? You can put it in the chat or. So our output right now is love apple. So I want to take this string, love apple, and I just want love. So a couple of ways you could do it. You can use the split function. So the split function allows you to take a string and choose any delimiter, any character. And then when the string, any instance of that character, it will split the function, it'll split the string into substrings, right? So what would I want to split on here? Yeah. So if I split on the space like this, it's going to return a list with two strings. Right? Oops. Split. Sorry. Okay. Output here is output is actually a list. So I need to grab the string. So let's see output 0, right? Output 0 will be this is it's a list with the string inside of it. So to grab the string, I need to get the right. So if I take output 0, which is the string, and then split on this, it'll give me that, right? But I only want the first. I don't want apple, so I'm going to take that, and I'll take the 0 element. Right. So that'll give me love. Okay, so we've got this kind of process here. I want to give you about 10 minutes to work on a function. So I want you to create a function, to write a function that using this example 3 to find the word in front of apple for all throughout the entire Wikipedia corpus. Okay? So we just did it one time on one sentence, right? So what you could do is you could take this example number 3 and put it inside of a function, right? And then for the corpus text, if you recall, here the code I've got. So you can open up the Wikipedia fruit file. You can run these, and these will just kind of clean the corpus for you. So this is the corpus. It's the list of sentences, and there are 275, I think, sentences. Right? You've got 275 sentences here. So I want you to, number 1, like write a function. If you put in one sentence, then it will output, it will find all the instances of apple and the word in front of it, right? In a list. Right? And then once you have that function, then you can do a for loop over text for each line in text, right? You can pull each line in text, and then within that for loop, you can run that function on that line, right? And pull out, if there are any instances of apples with word in front of them, it'll pull it into a list, right? And then you can append. So I think, like, what are some steps? Step 1, write a function. Using this one. Regex example 3 to find a word. So for this function, the input will be a string, and the output is a list of strings of the form some word apple. Right? That's the first thing, write a function, define a function. The second step is going to be write a for loop. Right? Run a for loop over text and apply your function from number 1 to each line in text. Right? You may need to create an empty list to hold your list of strings, right? And then when you run the for loop over text, apply your function to each line of text and append any strings you find. Append any strings you find to your master list in 2. Right? This is the kind of master list. Right? So this is a really common thing, right? If you're going to do a for loop and then you're going to like check each line of text, if you get some strings, right, some instances, you want to append those somewhere. You want to like hold those, right? So in part 2, before you do the for loop, you need to create a list, an empty list, where you're going to throw all the results, right? You create an empty list, then you run your for loop over each line of text, and you run that function. And when it returns some pairs of words, like something in Apple, and you throw that into your master list, right? So, okay. So define a function using regex. So first of all, I'm just going to take this. What do I want to call this? Apple words, I guess. Okay. So what's going into this function? What do I need to input into this function? What's that? Yeah, text, not text, because text is a list of strings. This function is just going to handle one string at a time. So we can just call it like S, or maybe sentence, like this, sentence. For each line, I guess we can call it a line, whatever. So if I pass a line into Apple words, then it's going to find all of these instances of the word plus Apple in the line. And it's going to return that as a list, right? It's going to return that as a list of strings. Now, if this sentence has no words Apple with the word in front of it, then it will return an empty list. If there's one instance, it'll return a list with one string, like love space Apple. If there are multiple instances, it'll be like like a list with the string love space Apple and fleshy space apples and something Apple, right? So, so it's going to return a list of strings, but it might be empty. So I need to like save that as something, right? So I'll call that my Apple strings, right? And now we can just return that. So that's all that function is going to do. Oh, I didn't want the but I don't want the Apple in there, right? I forgot. I gotta isolate the words, right? So I have these Apple strings, and they could be of the, like, they could look like this. Right? Let's just say it looks like that. Then I want to do, this is where I'm going to do a list comprehension. So, because I want what I want out of this list, love Apple, hate Apple, every Apple, all I want is, what do I want? What's the list that I want? I want to get rid of Apple. Yeah, I just want love, hate, and every. Yeah. So maybe I have a list here of several items, potentially. So this is a good place to do a list comprehension. Okay. So I'm going to call this frontward list, or I'll just call it front, like, I don't know. front list. Okay, so I'm gonna run this over for item in Apple strings. Okay. Now I've got this. So front list is going over love apple, hate apple, every apple. For each item in Apple strings, what do I want to do to that item? So if I get love apple, what do I want to do with that item? So I just get love and I isolate the back part. What's that? Yeah. So what am I going to write here? So so Apple string is the list, and then I'm running a for loop over Apple string. And the items, the elements within it, I'm calling item. So what needs to go here? Item. And then what? Split. And what am I splitting on? Space. Okay. That's going to take love apple. It's going to split on the space and give me a string with two strings. It's going to give me a list with two strings. But I only want the first one. Yep. Okay. Now we're really coding, right? Now we're getting into it. So you give me a sentence using regular expressions. I'm going to look for all instances within that sentence of any string that has a word, space, and apple, right? Every instance of that, it might be 0 instances, it might be 1 instance, it might be 10 instances. For each instance, it's going to take that word, space, and apple, and it's going to throw it into this list here called apple strings. Right? Then I want to process that list, right? Using a list comprehension. So I don't need a separate for loop because processing this string is something I could do using a list comprehension, right? So if it's like relatively simple processing, I can just use a list comprehension. I did this up here too with corpus. Right, when I read in the file, and then I read lines into the file, and then I used two list comprehensions to do some basic processing, right, for each sentence in that list, for each string in that list, right? I stripped it of any white space, that got rid of those like backslash ends at the end of the sentences, and I also I excluded any lines which were of length 0, right? So I got rid of any kind of empty lines, right? So I'm using list comprehensions here to kind of clean up my text. So, but I can also use these list comprehension here. So then for this apple strings, if I have, say, these 3, and this is just good coding practice too, right? So I just put in a hashtag here, and I kind of comment this out. Why do I do that? I kind of give myself like the most complicated scenario, right? Just to keep in my head, like just to imagine what apple strings might actually look like, right? Because if I just did like love apple with like only one instance, right, I might forget that there could be multiple instances here, right? So I want to like I kind of write an example for myself just to imagine like what's the most complicated scenario, right? And then apple strings that might look like this is in this list comprehension, I'm going to loop through each of these items. So, right, for item and apple strings. So first I'm going to get love apple, then hate apple, then every apple. I'm going to take each of those. I'm going to split it on the white space, which will give me a string with love, comma, apple. And then I only want the first word, right? So I'll take so I index that list 0, and it's going to give me that. So, and then I don't want to return apple strings. I want to return front list. Okay. Okay, so first we can double check that this is working. So what's my sentence up here? Or you can just write a new one. Let's say we have a new sentence called a new sentence with apples. So many good apples. Okay, so what should this, and then what do I need to put here in apple words? Huh? D, yeah. So I define this new sentence. I'm going to run the function on D, and what should this give me if I did it correctly? Should give me a list with what words? Yeah, with and good, right? So hopefully it'll isolate with apples and good apples, and it will just return with and good. So there we go. I almost wish we'd got a bad result, so we go back and error check, but we'll have plenty of chance to error check later. Okay, so that's the first step. I've defined a function using this regular expression to find the word in front of apple. So it returns a list of strings. Only containing the first word. Okay, so, all right, now I want to create an empty master list to hold. So this is just one sentence. This one sentence gave me 2 keywords, right? Or 2 words in front. But if I'm going to loop this, if I'm going to loop over every sentence in the text, right? And then if I could get 0 keywords, I could get 2, I could get 3, right? In any case, I need a master list to kind of throw those into, right? So let's just call that kind of keywords, and I'll make it an empty list. Okay, that's easy. Okay, now I want to run my loop over the text. So how do I do that? Okay, for line and text. So text says it's a list with 275 strings. So I'm going to run this for loop over it. For line and text, what do I want to do to line? I want to apply my function to each of those lines. So apple words is going to return this. And how do I append? Say I have one list and then I want to add, and then I have another list and I want to add their elements together. How can I do that? So append lets you add an element into a list. But if I append a list with, say I have a list with 2 keywords and then I append that to another list, it's going to put that list inside the list. Right, and I don't want that. So let me show you an example. So let's say like x is 1, 2, y is 3, 4. If I do x append y, it's going to give me the element 1, the element 2, and the element of a list with 2 numbers in it, right? That's not what I want. What I want is a list that's 1, 2, 3, 4, right? So do you remember how to do this? So it's actually it's super simple. We've done this with strings. Join. Not even that complicated. All you have to do is you just use the plus function. Yeah. So with strings, if you do a string plus a string, it concatenates the string into one long string. With lists, it's the same thing. If you have two lists and you do the plus, it'll concatenate the two lists. So x plus y gives us that. Right. So here, AppleWords line is going to give us something maybe like this. And we want to add that to keywords. So what should we do? Yeah. So we're basically going to update keywords with the elements of this list. Right? So, and this is, we know that this plus equals is the same as this, right? So it's just shorthand, right? So for each line in text, we're updating the keywords list, the list of keywords with our AppleWords, with the words from each sentence line. Right? So if I run this, and now let's see, we want to output keywords. That doesn't seem right. Let me go back and look at what text is. Before we do this, let's just check this, because it seems like we're not getting what we want. So I'm gonna kind of white space that out, and I'm just gonna check. For now, let's just loop through every sentence, and if Apple is containing that sentence, I want to print out what the Apple words are, right? And let's just see. That doesn't seem right. How about first, let's print line. So here's Apple. The word in front of it is the. As. And apples. Here's a. We wouldn't count this because it has this punctuation. Pineapple, didn't count that because it's not a separate, it's not a white space. Let's just check our this. I guess that's it. For some reason, I thought we'd get some juicier adjectives. Let me maybe I just want to do let's go into the text real fast and just double check. As and okay. So so we double check that these keywords are true. And yeah, so if we want to kind of go back to the fruit article, we can see where is that N coming from? Pineapple, apple. You're getting an here. Apple and include of and as the, okay. Those ends might be coming from the pineapple, I guess, maybe. Let's yeah, maybe did our let's do, we could just, maybe here we can change it to lower. Change everything to lower. That's right. I think once we change everything to lowercase, then it might have been like a capital A lowercase n, and it didn't, and it knocked out the capital A. If we convert everything to lowercase, then we get yeah. So okay, so that's an example. Like we just grabbed all of the words that are in front of apple, right? So using regular expressions. So let's I want to move on to introduce sorting and also sorting with different kinds of keys, and also the lambda function. So so let's start with the string again. Apples are so delicious. Now I want to split on the space. So you can use regular expression to split on, you could use a regular, like the regular split function, like this, to split S on a space. You could also use the, so in the same way that the string has the find function, where you can find simple things, right? The regular expression has the find all, which allows you to find like more complicated patterns, right? Using the regular expressions. So the same thing is true with split. So you can use split with a string just like this, and it will split this string on every instance of a space or whatever you put in there. Like you could split on an exclamation point, you could split on a whatever. You can I think you can indicate like several items that you could split on, multiple items. Regular expressions also allow you to split, but on more complicated regular expressions, right? That you couldn't put in a split function. So in any case, so this will do the same thing. If you do split with the regular expression space, it'll give you this list with all of the keywords. So let's say I want to remove punctuation, right? So I want to split on a space, and I also don't want any punctuation, and I want everything to be lowercase. So first of all, how do I remove punctuation? So how do I do that? I can make lowercase first and then remove punctuation. So first I'll do s equals s lower. Okay, so now s is all lowercase. Now if I want to remove punctuation, I can do, we did this before, find all A through Z. Put that in a string. So a regular expression. So this is like find all the words in S. Right, like that. And then I'm going to rejoin all of those. Well, I can just keep it like that. Yeah, so this is, this gives me all of the words minus the punctuation, right? And I only need, all those words are only going to have A through Z, right? So without any punctuation. And this would have also kicked out anything like, if say you had like an apostrophe, right? Say you had like Apple apostrophe S, it would have kicked out the apostrophe and it would have split Apple and S. Right? So if you wanted to include like an apostrophe, I think you could just do like that. So if you say like, I love Apple's, I love apples, or sort of, I love magnums. Apples. Right, like that. Okay. So if I, right, so I've got this apostrophe. If I don't include the apostrophe, right, it'll split the magnum and the S because it'll split on the apostrophe too. But I can add the apostrophe here if I want. And now I've got magnums as one, right? So it's up to you. And then, okay, so this is my keywords. So I'm just going to call these keywords. Or actually, no, sorry, I'm going to call these tokens. So when you're working with like, with strings and then you split, you know, if you're looking at like each kind of vocabulary word in a corpus or something, right, you might call it, like we call these tokens. So here's my, I'm going to save this list of words as tokens. Okay, and now I want to sort it. So I can just do token sort, but it didn't return anything. So this is this function is what we call like in place. So if you run a function on like on an object, say you run a function on a list or you run a function on a string, some functions do that thing and output it, but they don't actually resave the result to the original object, right? But if the function is performed in place, then that means the sorting happens and that new sorted list gets saved. It gets saved on top of the old one, right? So that's what in place means. And sometimes in Python, there'll be a parameter like, do you want this to be done in place or not? If you don't do it in place, it'll return the sorted list, but it's not saving it on top of the old object. But sort does work in place, right? So that's why it didn't return anything when I ran it. But now if you look at tokens, if you just look at tokens, now it's sorted alphabetically. Okay. Okay, so, but I want to introduce you to the sort key. So the function sort has a key where you can, it has an optional parameter called key, which you can set equal to some function. Okay. Now, if you, this function, whatever function you define is going to be the key that is used to sort. So if you don't specify the key, then sort is going to sort alphabetically, right? Just in the way that we expect it to. But say you want to, let's say you want to sort on, I don't want to sort alphabetically. I want to sort on the length of the string, on the length of the word, right? So I want to sort the list with the longer words, shorter words first and the longer words later, right? So you can define a function. Let's just call this word length, right? It's a really simple function where if you give me a word, I just return the length of that word, right? That's it. So I'm defining the function word length on the parameter word, on the argument word. What does this function do? It returns the length of the word, right? Super simple function. I define that. Now I can run tokens sort. I can run the sort function on tokens again, but now I'm going to specify, I'm going to set key, the parameter key equal to my new function, word length. Right? So I'm not even, when I'm, this is a different, like we've never done this before with functions, right? Where you would actually include the function as a parameter, right, inside of another function. Normally when you're saving something equal to a parameter, it would be like a value, a variable, right? But we're actually setting this parameter equal to a function, right? And this function is going to be performed on each item in this list, right? So here, like word length word, sort is going to take, it's going to loop through each item in tokens, right? Each of these words, and it's going to run this function word length on these items. And whatever that list is that's created by that function, that's what sort is going to use to sort that list. Okay. So the key for sorting is going to be the length of the words. Okay. So if I run this, again, it runs it in place. So it ran it and it saved it onto the object tokens. And if I run it, now they're sorted. They're not sorted alphabetically. They're sorted in terms of length, from shortest to longest. Okay. Sort also has another parameter called reverse. Okay. So you can, if you use this parameter true, it'll sort them in opposite order, right? So you can do, let's say, first of all, let's say we want to sort from Z to A. So in that case, we're not going to use this function. We're just going to use the regular sort, and then it'll, without the key, it's going to sort alphabetically, right? And if we do reverse equals true, that should give us in reverse alphabetical order, right? And then if you want to, we can also use reverse. And the key and the function to sort longest to shortest. Right. So here we just put in reverse equals true with the key word length. run that. And what should this should be, what are we going to get here? Yeah, exactly. So it should be this list, but backwards. So now it's sorted in reverse order, not alphabetically, but in terms of the length, right? Okay, lambda is kind of a little shortcut in Python, which is used precisely for this kind of situation, right? Where you have like really many functions that don't need a name, right? Like this function that we created, word length, here, right? We took the time to define this function, but this function is so simple. All you do is you get this is the input and that's the output, right? It's so simple, like, and also we're not even using this function out in Python. We're only using it inside of a, like, when we're calling another function, right? And we're setting a parameter equal to a function that we're creating. So in that case where you have this like mini function, right? This a miniature function, it is a function, but it's like a super simple function. And you're not even going to use it ever again, right? Outside of the context of this function, you don't even need to name it. So lambda allows you to define a function, a nameless function. And it's just like in place. You can define the function in place without naming it and then just move on, right? So here, I guess I should probably give this a header. So, because lambda is kind of, it's a special thing. So here, let's sort just by length. So this code here, key equals lambda t, length t. Okay. This code is doing exactly what we were doing up above, where we define the function word length, right? Here, lambda, so key equals, now when you have lambda here, this is where you insert the function, right? So lambda, it just means like I'm going to define a function now on t, right? If this mini function has more than one parameter, it would be like lambda t comma x or lambda t comma whatever, right? So you can have more than one parameter separated by commas, and then a colon, right, to indicate like, okay, those are so on this side of the colon, these are the arguments, right? The arguments for this function are just t, and then colon, what's the function do? If I give you t, you give me length of t, right? And we know that t is going to apply this, the sort function is going to apply this function to this list, and it's going to use that as the basis for sorting, right? So this function it's identical to what we did before. So I'm just going to run this on lambda t is length t. And so what should this give us? This is going to give us from smallest to largest, the sorting based on the length of the word, right? And you can do the same thing, right? The key lambda t length t reverse. So that gives us sorting by length of word in reverse order. You could do it. What's this going to do? What's this t0? Yeah, it's just going to do it in alphabetical order. Right. So we don't have to do, I mean, this is redundant because sort does this when you don't put in a function anyways, right? But this is what alphabetical order is, right? Actually, alphabetical order is this comma T1, comma T2, comma T3, right? Because sorting by alphabetical order, first you sort by the first letter, and then you sort by the second letter, and then you sort by the third letter, right? It's nested. So yeah, so if you run this, you'll get apples are delicious. You'll get them in alphabetical order. Last thing I want to show you though is you can sort on more than one field, right? You can do a nested sort. So here, here's my lambda t, and then I put in parentheses several things. So what's this going to do? Yeah, and actually maybe I don't want to specify this T0, but I can just put T like this. Okay. So this is gonna, first of all, it's gonna sort all of the words by length. And then if any of the words are the same length, it'll sort those ones by alphabetical order. Right. So do we have any? This is, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Let's see, do we have any words that are the same length? One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it did it by length, but then we didn't have any that were the same length. But okay, so I think we're about out of time today. But what I've introduced kind of the sort function and like some of the more simpler applications, and then like this idea of setting the function for key. We've introduced lambda, like a way to kind of make nameless miniature functions inside of as arguments, and also showing you that you can even create like multi-dimensional keys for like nested sorting, right? So these lambdas, again, you don't only use these in sort. You can use this lambdas in a lot of different places. Like the apply function, a lot of times we'll have there's an apply function, and when you're running things on lists, and a lot of times it'll be apply and then some lambda function. You want to apply like some function to a list or some array. So I have a couple of exercises in here that are kind of similar in structure to the one above. Like maybe you can create a token dictionary for a string, just like this, where you split it on this and then sort by frequency and alphabetically. I guess this is kind of what we did above, but then, oh yeah. So create a token dictionary. So instead of yeah, so like creating a token dictionary, again, this is like useful for corpus linguistics, but you know, if you split like this, if you split the string, now maybe change everything to lowercase, remove the punctuation. Creating a token dictionary is looping, like you loop through the items in this list, and as you loop through the items in the list, you pop them, right? So your list gets smaller and smaller and smaller, right? And as you pop the item, you add it to a dictionary. So you'll check like apples, you'll pop apples, and then you'll add it to a dictionary as a dictionary key. And then you'll update the value to 1, right? But then what if apples is already in there? So you pop it and then you look in the dictionary, is this word in my dictionary already? If this word is in my dictionary, I'm not going to add it again. Instead, what I'm going to do is +1. I'm going to increment the frequency of that particular word, right? But if it's not in the dictionary, then I'm going to add it in the dictionary and set the frequency equal to 1, right? And if you loop over the sentence or you loop over the whole corpus and you do that, then what you end up with is a dictionary with a list of tokens, and you have the frequency where in the dictionary, the key is the word, and then the value is the frequency of times that that word appeared in the dictionary, right? So I think that's where we'll pick up next time, is kind of creating this token dictionary. We'll do the same thing that we did in the example above. We'll create the function that does that over a single string, right? And then we'll loop over all of the strings in the corpus in the text, right? And apply that, like, and update the keywords for one sentence at a time, right? And then it'll output the dictionary, and like we'll see how many unique words are in the text, and also what are the high frequency words, right? So we can use sort. Once we have that, we can sort that dictionary based on the values, right? And the high frequency, so it'll sort it in terms of high frequency to low frequency words, right? And so you could identify, like, what are the high frequency words in this text or the low frequency words, right? So that's what we'll pick up with that next time. So. All right, thanks guys on Zoom. Oh, sorry, yeah, no class next week. Yeah, next week's a vacation, so I'll see you in 2 Fridays. Yeah. Yeah, you too. Bye.